Hello everyone, welcome back to my channel. Today we're going to talk about Git. We're going to talk about many concepts actually, but we'll start with Git. And to explain Git, I'm just going to show you how we need to understand Git. Okay, then we're going to do actually do it practically, and then we're going to move on to other DevOps concepts like CI/CD testing, deployment. Also, I'm going to talk about that, how you deploy your application, and more. Okay, but to explain Git, okay, you just need to we have a concept, we have a term called repository. This is just considered like a repository or a repo is a container for your entire project. Think of it like that. Okay, it stores every version of every file you have ever saved. It's like the game save data file that tracks your entire playthrough from start to finish. That's what the repo is. Okay, it's just a container for the entire project. Okay, and it stores every version of every file you have ever saved. These two things are how you define repo. Let me show you an example what we mean here with an actual application that I have built, my actual repository. This is my repos, this one. So if I go back to my this is a repository. See, this is my code, all my code. This is just my code, right? And this is the same as my folder here. We have the application. We deployed our code into the repository. This is called the repository. Okay, we can go ahead and see click here, and you can see this was last push was done 3 months ago here, right? And you can see the commits here that we committed 41. We had formatted 41 commits, right? So yeah. So whenever I committed, I fixed, for example, I fixed authentication here. I mentioned here fixed authentication, right? So like here, for example, so basically whenever I add a new feature, I commit it. So that's what we do. It tracks the previous list of histories, list of commits that you've done, all this. Okay, so if you want to go back, for example, to this commit, all I have to do is just go to copy this hash. There is a commit hash here, and go back. Basically, that's the idea. Like, these are all the changes. You can go back, revert back to the old changes if you want. So there are the 3-stage the saving process. Git doesn't just save everything automatically. You have to be intentional. Think of it like taking a photo. Okay, working directory, the room. Working directory is like the room. This is where you are currently typing. It's messy because you are still working, right? So staging area, this is the camera frame. When you run a git add, you're picking specific changes and putting them in the frame. You're saying, I want this part to be in the photo. Commit, when you run a git commit, you snap the photo. This creates a permanent dated record of what was in the frame. If you mess up later, you can teleport back. This part is important. You teleport back to the exact snapshot. Okay, that's what commit is. This commits that I showed you, this is it. Okay, branch is like the parallel timeline. This is the multiverse theory. Let's say the main branch, this is the true timeline where the finished working game lives. Okay, feature branch is what if timeline. Okay, you branch off to try something new, like a boss fight. Like if you win, you merge that timeline back to the true timeline, which is the main branch, right? If you lose, you just delete the timeline and the true timeline remains safe and untouched. So the main thing you need to get here is that whenever you start a new like project, for example, first thing you will do is create the main branch, right? Yeah, because initially you need to have a main branch. Okay, but after that, okay, you cannot start push any code in the main branch immediately without creating. You have to start working on the feature branch. Create a new branch, okay, based on the feature. For example, authentication branch, you can create a new branch, okay, that will be under the main branch for the feature authentication. Okay, then you will write your code here, right? Then if it is if the code is okay and you like it, then you will push the code from the feature branch to the, you will merge it with the main branch. Okay, if you win, we merge the timeline back to the true timeline. That's the idea, okay, of the branches. And we have remote versus local. Local, this is the version on your computer. Okay, like for example this one. This is the application that we were working on, right? This is the folder. It's right now, it's just on my local computer. That's it. Okay, but remote, this is the version in the cloud. Okay, just like this one, GitHub. I didn't push this application yet, but I can show you another application. This one, this right now is in the cloud, right? It's remote. It's what we call remote. Push sending your local save game up to the cloud so you don't lose it. That's the idea. We need to push this code to the cloud, to GitHub. Pull downloading the latest saved image from the cloud to your computer. Okay, why do we need this? Pull is just GitHub pull. It's just going to put it in the computer from the cloud, yeah, download it. We need undo button. That's why we need this process, because we need undo button. You can go back to any snapshot from 3 days ago if you break your code today. That's the main benefit of GitHub. Get all this process here. Also teamwork. That's the second benefit. 5 people can work in 5 different timelines or branches, and then carefully merge them together in one final project without overwriting each other's work. That's these two are the main benefit of everything that we've talked about until now. Okay, for teamwork and undo button. Okay, so right now what we need to do is actually open GitHub. I'm going to go ahead to my here. Okay, I'm just going to go ahead and remove everything here. I don't need this stuff. I don't need this one. I don't need this one. So I'm just going to go back to my, actually you need to sign in here. Let me show you. Let me start it from sign out. Okay, yeah, so this is github.com. okay, you have to sign up, but since I'm already signed in, so I'm just going to sign in, and I'm going to sign in with Google. Okay, now I'm going to create a new repository. Okay, this is a new repository. Repository contain the version history. So let me create, I'm going to name it I'm going to name it, let me call it task post or post manager or whatever, post manager app. Okay, you can name it as whatever you like to name it. Yeah, it doesn't matter. And you have an option here, choose visibility. If you leave it public, anyone on the internet can see this repository. You can choose, that's the issue, choose who can see commit to this repository. So I'm going to choose make it private. Okay, and I'm going to leave everything as it is. I'm going to create a repo here. Done. You just created a repository. Okay, now next thing what we need to do is actually go ahead and create. No, I'm actually going to go ahead and follow this button actually. Okay, this is if you are yeah. Okay, if you already if you want to create a new repository on the command line, we have to use this one. If you have an existing repository which you have already put it inside the existing repo you're working on, you can just use this one. Just add it here. Okay, but right now we don't have, right? So we just need to go ahead and do this one. Okay, so to do this, I'm just going to open here my full stack application. Go here. I'm just going to go ahead here actually. I'm going to do it here actually. I prefer to do it here because this is where my code lives. And yeah, so I'm just going to type cmd here. Okay, I'm going to add readme here. Okay, just post manager applications, just a file. And next I'm going to say initialize git, initializing empty git repository in this. Okay, and then I'm going to add git add remove.amd. Okay, you know, in the working copy amd reference will be replaced. The next git touch it, and the next thing I need to do is just git commit. This is my first commit. After this, yes, please tell who you are. Run git global. Okay, git config global. User.name, email, and user.john. Set your account default identity. Omit fatal. That is actually fine. Let's go ahead and do what we have to do this first. Git config. Okay, and global. Just going to type my email here, user.email, and I'm going to say John 35 at gmail.com here. .com. I think this is it. And git config and global user.name John. And just one more thing, the reason git before git, the reason git is working for me here, you have to download actually git from here. You have to download git from here. You just have to download it here. Okay, install from Windows, and yeah, install it. Next, and just restart the PC. It's going to allow you to write git command on the command cmd. Okay, once we have done this, then now we can just commit the application. Git commit -m first commit, and done. One file changed, 37 insertion, create mode. Now git branch dash m main. Okay, and git remote add. I'm not going to write it manually, I'm just going to add it here. Copy this one and I'm just going to paste it here, so it will actually push this code to the GitHub. And the last part, git push origin main. So I'm going to push the main here. Once this is done, our code will appear in GitHub. Sign in with the browser. Okay, fine. Authentication succeeded. Close and return to your application. And I think we have completed it. So now what we need to do is just go and refresh this one. Refresh this page. It's going to appear here. See, we just got our first commit readme here. Okay, so yeah, so this is our first commit. Okay, yeah, basically this is how the flow goes. Okay, we're assuming like this is your first commit, so this is how we commit to the application. And we have a flow that we need to follow actually here. 1 second, control. I'm just going to open this one. I have something here called git flow, git production flow here. So we have to follow this one every time actually. We have to follow this in the production environment, the steps. So now that we have done git init, let's create a local repository, and we added this one, readme, and git add first commit, then git commit initial feed. So let me just go ahead and do this one, git add. Yeah, git add. So git add means basically add everything. Git add like this. Okay, it's going to add everything, all the files inside this folder, folder. Okay, then I'm going to git commit -m. Remember these 2 points because we are going to actually use this more often. Yeah, feed initial, whatever we can, it doesn't matter, this is just something you write. Okay, you can just write here initial commit or whatever. Basically this is just like a description for the commit. Okay, yeah, done. So we just committed it, and then we are going to set the branch, so which branch we want to actually commit this change to. Of course, since this is the first or we want to commit it, we have to commit it to the main branch, because yeah, again, remember, you can't you should only commit to the main branch if you are 100% sure about your code, like you've tested and you have made sure that everything's working, and then only you can merge to the main branch. Okay, initially you should create a new branch based on name it based on your feature and work on it, and then merge only after you're 100% sure that you want to merge this one to you're ready to merge it to the main branch. Ensure the default is main. Okay, and then git remote add origin. Okay, we have here the origin is actually going to be our origin, our Yeah, this one, our where is it? This is our origin actually. Copy this one. No, not our origin, I mean this is where we want the code to be, right? Remote origin already exists. Okay, if it already exists, then we don't need to add it again. We just need to push the code to the main, right? Good. Push dash u origin main. Uploads your codes and links to the branch. Done. So we can go ahead on our main, on our GitHub repo here, and just refresh. See, all our code is uploaded now inside our yeah, everything is here now. Okay, yeah, now we have 2 commits, and this is basically how we do. This is one-time setup, remember. Okay, this is one-time setup. Okay, so in the development loop, once we set this up, we are supposed to actually follow this every time we make changes on the code or whatever. Okay, we forget this part because this is done. You do this one time. And the development loop feature here, first when you start a new task, we can start clean. Okay, we have to always, let's assume that you're working in a group or a team. Okay, like the main will always change, your repository will always change, right? So you have to always pull the latest code from the repo, because other teams might update the code or make change or merge. You don't know, right? So what you need to do first is just git checkout main. Okay, go to the main. Okay, your branch is up to date with origin.main, and then what you need to do is just git pull origin always before you start writing anything. Okay, done, already up to date, so no need to do for us because we just updated, right? So always we need to do that. And then once we are up to date, okay, now we can just go to git checkout here. Okay, I'm going to go git checkout b. I'm going to create a new branch. Okay, because right now I want to work on the login system or whatever, authentication or login system. That's it, login system here. I'm going to type login system. Okay, or whatever, it doesn't have to be login actually. Authentication, whatever you want to, whatever feature, let's say we want to work on today. Okay, I'm going to create a new branch with that feature name. Switch to the new branch. Remember, you cannot work on the main branch, so you have to work on a new branch with feature. This is very important. And then we can make change on our code. Let's go ahead and do the changes, no problem. Code.view, I want to add some stuff here. Let's say I'm not going to do much. I'm just going to create some folder here. I'm going to call it auth, and I'm just going to rename here. I'm just going to create a new folder here. I'm going to call it auth. I'm going to put under it sign up folder, and under auth I'm going to say here login. Yeah, that's about it actually, just for the sake of just to see this one. Okay, and once I made these changes, what I need to do is just yeah, git add all stage changes. Then git commit -m feed add login. Okay, this will save a local snapshot. Okay, on branch feature authentication, nothing to commit. Working 3 clean. Okay, let me actually make sure that it's actually updated. Yeah, so I just created a folder. Okay, maybe that's the case. But anyways, we can just get push here, uploads your work in progress branch to GitHub. Okay, we can just get here, push origin feature, and I'm going to name it. No, I'm just going to feature, name it authentication. So yeah, so let's see what happened here. Yeah, this is my initial commit that I committed before. Well, these are the branches. You see, we have 2 branches here now. This was the main branch, this is the feature branch. The feature branch, this branch is up to date with main. And yeah, so 2 branches here. I created the main branch and feature branch. Yeah, so that's about it actually. Let's just go ahead and do this one, feature branch. Open this one. You go to ops and yeah, I think I didn't save this one. No, it's under auth actually, and it's under app auth. So once the feature is finished and tested, bring it back to the main. Okay, so git checkout main, just switch to main. Okay, git checkout main. Okay, switch to branch main and then merge this one. Git merge feature login combines the new feature into the main code. Git merge feature authentication, already up to date. And yeah, so now we can push to GitHub, updates the live version. Git push origin main, everything's up to date. And now we want to delete the old branch. We can just git branch. Once we want to delete it, we just go ahead, features, feature authentication. Removes the temporary workspace that we created, so we just delete that branch if we don't need it. Yeah. So basically this is the new work. Okay, creates a safe parallel invoice, saves milestone in history. So what we need to know is just try to understand as much as possible these things, because these are what we will work with mostly. Okay, our work will be here on the development loop. In case we want to like roll back or something like that, you can just go to Git and I will show you how to do that. And you can go here, we have a cheat sheet actually. It's going to show you exactly what to do. Okay, of what we need to do exactly. This to make commit, we know about this. To move between branch, just git checkout. We know about this. To create, just git checkout -b to create a branch. And to discard changes, and to edit history, to commit to diverged, add remote, push your changes, pull changes, and yeah, push your changes. And we have also here edit history, undo the most recent commit, keep your working directory the same. You can do this one, and undo the failed reverse, change commit message, add to forget, and check out. So basically this is what we need to know about Git. I think it's time so we can move on, because it's enough for Git, and you can learn other things by yourselves. And that's it. Just keep this mental model, and we learned about Git. Okay, now we're going to go with the testing. We finished GitHub. Now we will move on to testing. What we are going to do is actually our existing application here, this one. Where is it? It's this one. The simple application that we created in the previous video. Okay, and we use the 3-layer architecture and everything. We're just going to implement testing on this application. Okay, and also we can appreciate why this 3-layer pattern, service and repository pattern, is useful for testing, also for maintainability, also make it easier for us to test also. So we can follow this architecture also. And then we'll move CI/CD, how to automate everything, testing and everything. And we'll learn Docker also. So let's go ahead and start now. So basically there are three levels of testing. Okay, we have unit test. This tests a single function or service. Okay, and integration test tests multiple layers together, like API plus database, and how the database interacts with the API, how the API interacts with the database, everything. Okay, that's the difference. Unit test might test just a single function on the application, like create something, or like delete, or one of the single function, right? End-to-end test the full application, the UI, how the UI interacts with the API, how the API interacts with the database. End-to-end testing, full testing. Just remember this: unit test, integration, and end-to-end test. Testing pyramid, important concept. We have end-to-end testing, few tests, integration testing, some tests, unit test, many tests. Yeah, so we'll have many tests for end-to-end, for unit testing, and for integration we'll have only few tests, and end-to-end we'll have also few tests. Okay, so we have unit is just a small function, the unit test, which is fast. For example, post service. Okay, you can test the post service. Integration, we can test the API, for example, which is end-to-end. We can test the browser slow, user deletes post. Okay, so most of our tests is going to be unit test. Okay, so we're going to use Vitest, which is the most common library that's used with Next.js for testing. So I'm just going to use this one. I'm going to go ahead here. I'm just going to type cmd here. Going to install Vitest. It's not working for some reason. Yes. For some reason the application is not working actually. I'm not sure because it has nothing to do. Let me just put it here. npm install, or let us go to the doc as usual, Vitest here, and see what we will get. This is the next generation testing framework, Vite native testing framework. It's fast and stuff. So first, lightweight. Yeah, we're just going to go ahead and get started with it. Vitest is the next generation. So this is the command that we need. But you can use pnpm also, it doesn't really make a difference. Let's try this one. Done. So Vitest is installed. It's recommended that you install a copy of Vitest in your package. Use one of the methods listed above. However, if you prefer to run Vitest directly, you can use npx Vitest. So to write test, it's just we will write a simple test to verify the output. For example, here this is actually a good example. So just to get to familiarize ourselves with the syntax and what it does, next, in order to execute test, add the following section in package.jsn. We have to add this one actually, scripts test. So we could say npm, we can go to package.json here and add it. You can add it anywhere under Prisma seed here, whatever. You can put it here and just put comma here and save it. Okay. Only 1 second. We don't need to add a new script. Just copy this one because already we have here, right? So just put it here, paste it, and add comma here, and that's it. And let's go ahead and create under lib. I'm just going to create just sum.js. This is just to test sum. I'm going to add a basic function here. So this is a function that just takes a and b as an argument and returns a plus b, the answer, the sum of both the arguments. So I'm going to create one more here for testing. I'm just going to create here sum.test. Actually, this is how we write the name of the test. You just have to type the name .test.js or ts, it doesn't matter really, but the important part is the middle one, the test name. It has to be test. And then we're just going to import expect, okay, comma test from Vitest, okay. And then we're going to import sum from sum.js, which is from there. We're importing the function, okay. And then I'm just going to use test, and I'm going to add, I'm just going to mention what this test does actually, just a description. Think of it like a description. 1 plus 2 equal 3. So I'm just going to add comma here. I'm going to put here, and I'm going to put like this, expect sum 1 comma 2. So I'm saying expect the sum. I'm using the function to be basically telling it expected to be 3, and so that's it. That's all we have to do. But what I'm saying here is that, okay, I'm importing both test and expect from Vitest, and I'm importing the function sum from sum.js, and then I'm going to use test. I'm going to add the description here for test, which is the just to name it, that describes what this test is going to be. I'm telling adds 1 plus 2 to equal to 3, and then I'm going to open a function here like this, like a function here, and then I'm going to write expect sum 1 plus 2 to be 3. By default, test must contain .test or spec in their file name. In order to execute the test, add the following. We did that. Now we just have to run this command. It's going to work. npm run test. Okay, so we can go ahead and go to any terminal here. Just type npm run test and see what happens. Nothing, because remove this one. So this is what we got. What did we get? Notice suit found in here, and 1 failed. Noticed watch file change. Let me see, what do you mean by that? Noticed suit found in the all test failed. So let me just do it again. Let me do it again. So it failed again. So let me see why it failed. Let me just make it npm run test. I did that. Let me go ahead and go to package.json. Let me make sure that I'm actually doing it properly. Vitest. I did that already, I think. Here. Oh yeah, npm run test should work properly. I think this is not saved. This could be the issue. And some.test also, I'm not sure if I saved this as well. So let me go ahead and try this one. Yeah. So once I saved it, it was successful. You see this one? Adds 1 plus 2 to equal to 3. Test file passed and test passed. So basically this is what we mean by unit test. Okay, configuring, yeah, this is unit test. So now that we know the unit test, okay, how to do a unit test, actually I want to go ahead and yeah, so basically this is just a simple example of how to perform a unit test. Okay, yeah, we added the script already, and we have to create this config actually. Vites.config, let me see. I didn't have to do it, it worked, but let's see. Vites.config, I think it is on React. We have to do this one, not in Next.js, because Next.js, I think it's not, Vitest is not showing actually here. Anyways, you just follow this one and npm run test. The unit test, we test post service only. Okay, we mock the repository, so we're going to test the post service, because unit test must test one thing only. We're going to use this one. Yeah, we're going to go ahead and test the post service. I'm just going to copy this one, okay, because I don't see why we write it down. So I'm just going to go ahead and change this instead of actually we have, it's recommended I think to create a new under tests under app, and we can just create here service dot test dot ts, of course. I'm just going to paste this one, see what happens. And this test is supposed to check if the service is actually calling the repository correctly. Okay, And I know we have new terms here, describe it and expect and vi. What we can do is just go ahead and simplify this to ourselves. And go back here and type expect. Let's go ahead and try to understand each. Let's start with expect. Okay, expect is used to create assertions. In the context of assertions are a function that can be called to assert a statement. Okay, a function that can be called to assert a statement. Bytest provides child assertion by default. So just so for example, code asserts that an input value is equal to 2. Okay, if it's not, the assertion will throw an error and the test will fail. It's test function, but the console. Okay, expect has no effect on testing types. Assert, so it's just going to assert expect input, okay, to be like this, to equal to like this. Basically we're just asserting to create assertions. Okay, in this context, assertions are functions that can be called to assert a statement. Okay, now let's see what's describe. Let's see what describe does. Describe vi it 1 second. Yeah, we can continue now. I think we should go ahead and try to understand our code here as service.test.ts, because actually this is what we are going to use mostly. Okay, so describe is used to group related tests together. Think of it like a folder that contains multiple tests. This one, okay, this is like a folder. Okay, think of it like a folder that contains multiple tests. Okay, its job is just to group related tests together. Okay, and you're saying all tests inside here are related to post service. That's what I'm saying here. You see, I'm just mentioning that all tests here are related to post service. Why it's useful? Organize test, makes test output readable, allow nested grouping. That's why it's useful. So describe post service, and this one, describe get all post. Describe basically allow nested grouping. Okay, test output will look like this one. Post service, get all post. So basically that's what we're doing here. Okay, when we say describe, we're trying to group all the tests inside this one. We're saying all this test belongs to post service. It, the single test case, defines one specific behavior you want to test. That's it. Okay, like here we are mentioning it should return all posts, right? And so what it means, it should return all posts. Okay, you're describing what the code should do. Okay, and good test read like English, like post service should return all posts. Structure what should happen, the test logic will be inside it. Okay, so example, it should create new post, it should create delete post, and so on. That's the idea. Okay, so expect, which is the third point here. No, let me see, this is it, right? Expect, which is the third point here, this one, and we used it also in sum, checks if the result is correct. This is called assertion. Okay, like here I'm saying expect result dot length to be 1, right? Meaning I expect the result length to be 1. If it is not 1, the test fails. Basically, that's what it means. Common assertion equality, expect common value to be 10. Object comparison, you can also compare an object. You can say expect object to equal to name equals to John. You can also do boolean, expect is logged in to be true. You can also use a function expect mock.getAllPost to have been called. Function must be called at least once, meaning that's what it means basically, to have been called. So this is what it means. Okay. And VI is Vitus mocking utility. VI is a Vitus mocking. It allows you to mock functions, spy on functions, replace real dependency. Imported here this one. Okay. It's used for mocking functions, spy on functions, replace real dependencies. So we use this one to create a mock function here. Const mock repo. It's just a mock repo. Okay. I use vi.function.mock resolved value. Resolved value, and I added this one, this function. It's just a test, a fake function. Okay. And create post vi.fn, delete post vi.fn and stuff. Right now, because we are testing this one, we're not testing others. Okay, instead of calling the real database, the test uses this mock function. Okay, mock returning data, we have this one. This is the data. When this function is called, it returns this fake data. Okay, simulates the database response basically. Okay, so the full flow is like this. We create a mock repository like this one. It's mock repo. It's a fake database. Inject into services. Yeah, we have to inject it to services just like we did before. And you pass the mock dependency. This is called dependency injection. Run the function. Okay. Const result await service dot assert results. Assert result. Expect to be done. Assert behavior. And to have been called. Check the service called the repository or no. Make sure that there is the actual result here. So this is just testing. So basically it's testing. It's just testing. Okay. So these are the tip. Yeah, this is fine actually. Now what we need to do is just, now that we understand this one, okay, this is yeah, now that we understand what each means here, each point here, what the code means, now what we need is to actually do it, taste it in our application. Let's go ahead and do that. Yeah. So we did not test that. We're not using test database, and yeah, we're just using this one, unit test for delete. No, we are trying to test the so what we need to do right now is just, I think what we need to do is we save this one. Okay. Just to show you how simple this is actually. I think what we need to do is actually export this one, because we are going to do this one, right? We have to export this one. It has to be exported. Cannot appear here because what? How else I'm going to get this one exactly? How am I going to import this one? 1 second. I just need to be able to access this one because I'm going to use this one. We are supposed to do dependency injection also. Okay, it's already tested here. You see, it's going to do that by itself. See, we are injecting here. You see this one, const service. new post service. Okay, we're injecting this fake repo onto this service. Okay, now it's going to run the constructor and the post service, right? It's going to call, we are going to call this get all posts. Okay, so this will give us the idea of whether service.post is working or not. So we'll save this one. I'm just going to run npm run tests. No, I can't run it from here, so let me go ahead and try here. npm run test. So import post service. One failed, one passed. Which one actually failed? Which imported from okay, I think the main issue here is the import, actually, the way it's imported or something. Let me go ahead and open to the side here. This is the service. No, this is not the service, actually. This is the repo, I think. Service post is actually the repo or the what? No, this is the, yeah, this is the service post. Yeah, this is correct. So we are importing this one from here, and let's go ahead and try it out here. Remove this one and try to import it using a different way, like yeah, so let's see if this will work. Yeah, so one pass, so we should return should all one return pass. So it basically passed. The test was passed. Okay, one passed. No, let me just, to make sure, just remove this old test. We don't need this one actually, because it's confusing me and we don't want that right now. Test removed, yes. Yeah, so but it passed. You see, this one should return all posts. It's passing. Okay, basically that's what we did here. So it's very simple. Again, it's just a matter of practicing it and you'll understand. And let's say we did a unit test for delete. Okay, so what we need to do is just add this one. To do unit test for delete, we just have to add this one. We're going to do the same thing, but what we are going to do here is that mock repo, and we're going to add delete post here, mock result value, and we're going to pass the repo, to inject the repo to the service, and we're going to await the result of delete post. Okay, which is 1. Okay, we're giving it the ID, right? This ID for this one, and once result.id to be 1, and mock repo.delete post to have been called with 1. So that's the idea. Integration test. Now that we know the unit test, I think we are pretty comfortable with the unit tests now, so we can go with integration test. Okay, so now we test the API, service, repository, and database. We do not mock repositories, we test real behavior. Install test tools like super test here, and example of integration test. Let me go ahead and install super test. Let me stop this one. Yeah, give it some time. and we have this unit test. Now integration test. So I installed this one. So now what I need to do is actually create this one, post .api.test.ts, create it under the test folder, paste it here, and then I'm just going to copy this one. This is the integration test, so paste it here. Yeah, so I don't think it's installed. 1 second. Super test is not installed. So what this test checks is basically the API, how the API interacts with the service, with the repository, with the Prisma, with the database. This is integration testing. This is integration testing. Example of integration testing. Let me go ahead and do this. Yeah, so super is not installed actually. Okay, maybe your request is defined but never used. That's something interesting. Import request from okay, so okay, let us just see what we will get. For now, just keep it disabled for this line, okay, just for the sake of testing. Let's try to understand what this code will do. Okay, so basically it's going to do what? Describe, get, it's going to get api.posts, it's going to get the data from there, and it should return posts. Okay, and new request, this one, this is the post. I think no, I think it was fine here. Post request here, localhost API. It's going to fetch, basically it's going to put it in the request. Okay, and get, await get, okay, request as any data, await response. Wants response to be, response status should be 200, and change it, the data to array to be true. So we should just receive an array basically. Let me save this and try it out. We're testing the API here, right? So let us go ahead and try this out. npm run test. Yeah, so I think we have an issue here. What this test does, let me just pause the video to save time. So now we're going to go through the integration testing. I'm going to go ahead and have this code right now here. This is going to test how the API actually starting from the API to the service to the repository, and what data it's going to return from the database, everything, full cycle. So this is important. That's why we need to actually go ahead and try to understand what the code will do. Okay, first thing what we did is import the testing utilities like this one, describe. We said that it's a collection of different test functions, like we created it, single test function, expect, just to assert or to tell it, like tell the function or whatever, yani, how it should be. what result it should expect يعني. Before all and after all we have also. Before all means run once before all tests. Okay. After all means run once after all tests. This is the difference. And example idea here we have describe posts. Yeah, let's go ahead and start here. Let's create a post ID here. Before all, async, await Prisma post, delete many. Okay, run once before all tests. So we're just saying delete all the posts, delete all the posts before running any tests. Okay, that's what we're saying here. This is used to clean the database, and remember in integration course, in integration test, we have to have another test database. Okay, to test it as in a production environment. We cannot test on the production environment. We have to use another database for test, separate database. And after all means runs once after all tests. Okay, this one we are going to disconnect. Disconnect after all the tests are completed. That's the idea here. And so import your API route handlers. We have to import the API route handlers here. We have get, post, delete, and patch. We were trying to import it from the route, from our main API. Okay, it will feel probably like this one. Yeah, instead of calling an HTTP server, the test calls these functions directly. Basically, yeah, we're just calling these functions directly. This ones. Remember, we created on our API. We have get here, and we have post function, and we have delete and patch, right? So that's what it's doing. It's just calling this directly. And import Prisma. Yeah, this imports database client from Prisma RM. You use it to clean the database and disconnect after tests, basically. So yeah, so import request type. The class comes from Next.js to represent the request used in the app router's API route. So this is what we are going to use. Const request equals to new request, this API post. Okay, this is to test for it. Okay, for get, basically get API post should return posts. So basically we're just going to use the syntax, just going to call, put the request here, okay, and use get request here. We're going to pass this request to get and wait for a response. And yeah, rest status should be 200. So the array has to be the array and to be true. So then we have post here. Post basically yeah, so yeah, so this is to clean up after reset. After all tests are finished, close Prisma database connection. Without this test may hang. So we have to remember to add this one. And test get endpoint, we just defines a test like this. Create a request. We create first a request this way, simulate a get request basically, and then call the API handlers that we have in the route here, get and rec, and then runs your route handler. Okay, parses the response. Here we have to parse the response, read the JSON returned from the API, and assert status code. Okay, check this one, and assert response shape also. Ensure response is an array of posts. Okay, it has to be an array, right? So the same idea actually for the this is for For the post, let's see how we do it in post. If post, test creating a post here, same concept, we're just going to create a new request here, and but here we have to mention the method post here and the body, and we should add a random body here. Okay, test post and stuff, and title and contents, and just run this one, parse it, and create the add post id equals to data.id. Yeah, this is for the post, and data.id. Yeah. So res.status, we have to be 100, and make sure that data.title is actually test post. Same thing we did for patch. Okay, same idea basically, and delete also, it's almost similar. So this is the concept, the mental model that we need to have. And I already run this test, and I run it's all past this test. You see, get should return and post, patch, and delete. So that's what we need to remember. Memorize this pattern, just understand the pattern, the mental model. So this is the integration test. We tested the API, services, and database. And unit test, we just test each single function one by one. So this is it. An end-to-end test is the full system. Now we test the full system. Okay, so now that we have this two tests was successful. So now let's go ahead and test the full system. End-to-end, basically we use Playwright. This is best for Next.js actually. For Next.js, Playwright is recommended. Let's go ahead and install Playwright here. Let me just stop this one. Install Playwright. Okay. And just copy this one. Okay, the name is just going to be post.e2e.spec.ts basically. And let me just add it here on test. I'm just going to paste it here, and I'm just going to copy this one. Okay, so we just saw this one, and we're going to go ahead and do the end-to-end testing. Where were we exactly? Yeah, I just want to copy this one, right? Let me copy this one and paste it here so I can try this one. Yeah, so I think, what is this? Testing your React component. This is optional, so leave it. Mocking external dependencies. We did that already. And mocking Prisma. We can mock the real testing strategy for my app. Yeah, before doing this, let us just go ahead and check the end-to-end here, how it will work. Okay, so basically import test and expect from Playwright to test, and test delete post from UI, async page go to this one. So it's supposed to go to this one, and click delete. So I'm just telling it to find this text, delete, and delete it. Click it, and expect the page locator text equals to post deleted to be visible. Post deleted to be visible. That's the idea. So we should have some should return a message like post deleted or something. Anyways, let us go ahead and try it out once, and then we'll move on, because we have spent so much time on this already, and most of this we already understand the concept, so I don't think we should spend any more time on it, and we will move on to CI/CD. Hello. Okay, let's continue. Let's go ahead and do the testing actually for this one, for end-to-end testing. Then we're going to just have a look at the best practice and move to CI/CD and npm run test, just to see exactly what it will do. Playwright test did not test to be called. The most commonly calling test in the configuration file. So we have an issue here for this code. Yeah. So let's follow the best practices here. Mock external systems. We have to mock database, Redis, rate limit, and keep tests simple. But don't test everything. Basically, just one behavior per test. Use clear test name. Okay, and basically add test to pipeline. Add test to pipeline. We are going to add test to pipeline. This is what we call by CI/CD actually. When we say CI/CD, this is what we mean. We have to go here and just to see what exactly is CI/CD. CI/CD stands for continuous integration and continuous delivery or deployment. These two distinct but connected practices. Okay, continuous integration means every code push triggers automated checks. Okay, this is continuous integration. Dependency, what gets automated? Dependency installs, linting, unit tests, integration tests, Docker build, all this stuff will be automated. Okay, it will be automatic. It will be done automatically. We don't have to do it manually here like we were doing npm test and stuff, and yeah, we don't have to do this stuff. Okay, linting is just like this one. Let me show you here. For example, let's say I stop this one, npm run lint. Yeah, so this is linting. This is what we run when we want to see what are the error in our application. This is what it means, linting. And so basically this will be done automatically. Automated. It's going to check for errors, it's going to check for the unit test, npm run test, all this integration test automatically. That's continuous integration. So whenever you push the code, it will automatically go through all the steps. Continuous delivery, every passing build is ready to deploy with one click. Staging deployment, smoke test, approval get, all the stuff is with every passing build is ready to deploy with one click. That's it. So continuous deployment, every passing build deploy to production automatically. Production deployment, health, check, rollback, on failure. So all this stuff is actually done automatically. We don't have to. That's the idea of CI/CD, continuous integration and deployment. Okay, automates all the process that we were doing just now. Why CI/CD matters? Real problem it solves. Without CI/CD, developers work in isolation for weeks, merge thousands of lines at once, big bang merge. Bugs are impossible to isolate. Deployment are manual, 3-hour ordeal done by one person on Friday afternoon. With CI/CD, every change is small, tested immediately and deployed safely. CI/CD principle: if it hurts, do it more often. Frequent small deployment are safer than rare large ones. The pain of deployment is proportional how frequently you do it. Okay, so we're going to use something called GitHub Actions. Okay, is an event-driven automation platform built in GitHub. Here is the anatomy. So it has workflow, a YAML file defining the automation, like this one. .github workflows ci.yaml. Okay, triggers on the event, start the workflow. Okay, push to main, pull request, Okay, so yeah, the workflow, yeah, this is where we define all our the flow, basically the pipeline. So this one basically ci.yaml and job, a unit of work that runs on a VM. Build, test, deploy. Steps, a single command or action in a job, like for example npm install or docker build. Runners, the virtual machine that executes steps, basically. Ubuntu latest, Windows latest. Action, the reusable step in marketplace. Secret, encrypted variable for sensitive data, like this one. Matrix, run job with multiple configurations. So this is an example of production CI/CD pipeline. So you can see here we put the name here, production pipeline. On means this one, the trigger, the event that starts the workflow. We put here push, branch, main. Okay, pull request, branch, main. Okay, and env is just it's just the yeah, env image name, my app registry. Jobs is a unit of work that runs on a VM. Build, test, and deploy. So stage one we have test, name, test, and lint. So this is for testing and linting. Run as. Steps, we are mentioning here what to use. Names, and here name, install dependencies, run linter. Okay, so we mention here, see, the name, run linter, and we mention also run. Under run we have to mention the command here, npm run lint. For test we mention here the name, run unit test, and under run we mention npm run test. Okay, so upload test coverage. So the stage one, basically we have three stages. I think this is the first stage. Just we run the basic test and unit test and lint and dependencies on all the like npm ci and all that stuff. We run this one, right? Stage two we build. Build means basically we use docker build and push. So only run if test job passes. If GitHub is this one, use this checkout login, and it will build this one. Okay, and if stage 3 will deploy to Kubernetes. For example here Ubuntu latest needs deploy here, and so this is actually for production environment, but I think we should go through CI/CD detail. And before moving, we just have to understand Docker, because the problem Docker, what's Docker? It's basically containerization. It means before Docker, application run directly on the servers, right? You have to have a server in order to run the application. Each server needs specific OS version, libraries, runtime version, and environment variable, right? Works on my machine was several problem. Like maybe it will work on your machine, it will not work on another developer's machine, right? So QA and production environment all differed. Okay, setting up a new server took hours or days. Okay, that's what Docker solves. Without Docker you will have many it works on my machine issues, but with Docker you have the same container, runs everywhere identically. Okay, so without Docker server need manual setup, like hours, but with Docker starts the application in seconds, right? Without Docker, dependency conflicts between application, and with Docker each container has its own isolated dependency. And dev, staging, production environment differ, and same image used across all environment. Scaling requires OS privilege scaling by running more container instance. So Docker, this is the difference between them. Okay, so how Docker works, we will have a Docker file. This is the recipe or blueprint, text file with instruction to build an image. Okay, image is like a frozen cake, read only. Layered file system snapshot, immutable. Container, a running slice of طيب okay, so this is how it works. I think it's better if we see it in practice. So yeah, multi-stage build, why they matter. A naive Docker file copies all source code and dev dependency into a final image, resulting in 800 MB images. Multi-stage builds use separate stages, one for building with all tools, one for the final runtime minimal. This reduce image size, reduce attack surface. Yeah. So Docker Compose, local development stack, we have this one, okay, and Kubernetes. I think we should also just have an idea of what it is. Docker solves how to package an app. That's the idea of Docker, basically how to package an app. But in production, you need to answer to much harder question. What happens when a container crashes? How do you run 100 copies of the same container? How do containers find each other on a network? How do you deploy a new version with zero downtime? Kubernetes answers all this. Docker is like shipping container. Yeah, just like a shipping container. Kubernetes is like the entire port. Crane, systems, logistics, network that manage where the container goes, how many arrives, what happens when one fails, and the what in the water. Okay, Kubernetes architecture, we have control plane. It manages the entire cluster. API server, this is the entry point for all commands. etcd, it's key value. At this point we can try to understand it like separately, and using when we go ahead and try to do it the lab. So testing, we went through testing actually, we don't need to go through it again. And monitoring is important. We said that monitoring is non-negotiable. Deploying without monitoring is like flying blind. You don't know if the app is healthy, slow, or crashing until user complains. Monitoring gives you visibility and system behavior. I think we took this before also, but we will try to do this one in real world. We'll use Prometheus or something. And this is why Prometheus, the difference is, unlike push based monitoring where apps send data to collector, Prometheus actively scrapes metrics from HTTP endpoints at regular interval. Every monitored service exposes a metric endpoint, and Prometheus fetches it every 15-13 seconds. So it just fetches every 15 seconds, evaluates alert every 15 seconds. That's the idea. 4 golden signals. We have 4 metrics. We've talked about this also before. And the latency, this is the time to respond to a request. Okay. Traffic, how much demand is hitting the system. RPS drops to 0, service downtime. Error rate to failed requests. Saturation, how full the system is. So this Prometheus uses Prometheus query language. Grafana, Prometheus stores metric data, but its built-in UI is basic. So Grafana is just connects to Prometheus and dozens of other data sources, turns raw metric queries into beautiful interactive dashboards. Standard visualization layer in Kubernetes monitoring stack. So basically just know that Prometheus gets the metrics for you, okay, the details, and Grafana just takes this metrics and presents it to you in an interactive dashboard, beautiful interactive dashboard, Grafana. So for visualization and dashboard. So it has key concepts, data source, okay, dashboard, collection of panels, query. It uses PQMU expression that fetch data from data source, alerts, annotation. Yeah, so we will have application overview, dashboard, cluster, and yeah, installing full stack via Helm install monitoring stack, add Prometheus community, Helm, Prometheus, Grafana, and all that stuff. And I think that's about it. Postgres, we already talked about it. We've talked about it. Caching also, we have already talked about it. And we have infrastructure as a code, means defining your infrastructure: servers, network, database, Kubernetes config, and text that are version controlled, reviewed, and automated, just like an application code. Benefit: reproducible environment, audit trail, and team collaboration, disaster recovery. So this is just like GitHub but for DevOps, meanings defining your infrastructure: network, database, and text file. So we can use tool like Terraform. This is a cloud infrastructure VM. HashiCorp configuration language which is using Kubernetes YAML. Okay, so yeah, 12 factors material building software as a service app that are portable, scalable, deployed in modern clouds, written in Hurricane engineering. So we just have to follow this one. Code base, one code base tracked in VCS, many deployed. One GitHub repo deployed to dev staging, and explicitly declare and isolate dependencies like package, requirement text, no system library. Config, store config and environment variables like here. Secrets, config maps. Treat database cache as attached resources. Swap without code change. Strictly separate and build and run stages. Docker build, push, Kubernetes apply, execute as stateless, and scale out via process model, export service via port bounding. And yeah, this details actually we are going to go ahead and do it practically. That's what I'm thinking. I will try to do it practically. Already we have one lab here, we can set it up. I think that's much better than talking about it in theory. I'm just going to try to build it actually. GitHub and trigger and all that stuff. Deploy to Kubernetes and set up monitoring. Okay. I'm going to try to do it all. Okay. I'm going to try to do it all so we can understand how it all connects together. And let me just take a quick break and get back. Okay, now we're going to set up CI/CD pipeline with our project. So yeah, we said CI means continuous integration, run test on every push. CD, continuous deployment, deploy automatically. So deployer push, developer pushes, GitHub action takes it and starts the installing independent dependencies, and then run tests, then build project. So I'm supposed to create a folder like this here. I'm going to create a folder. Inside it I'm supposed to put ci.cml YML. So let me go ahead and create a folder here, or I think maybe here just create a folder, name it this one, and inside it just put a file here, paste ci.yaml, and I should have a basic CI pipeline. So just like we said, on is basically is going to trigger this one, it's going to push to the branch, and the jobs, the task that it will run is those as follow here. It will install dependencies, then it's going to run the tests and generate Prisma client and so on. Also build is what we use. It's like npm run dev, but build is for production. We use it for production. So this is what we need. So we just copy this one and paste it here. Okay, and paste it here, save it. So we can add test scripts here. Add this one. Test we already added, so I don't think we need to add tests, but add it anyways. We'll see what we need. We go to package.json here, and I go to script, and I don't think we need to add for test because already it's inside, so no need to do that. But for build, we just added build. It's already there, so no need to add it. Actually, just check it if it's not there and add it. If it's there, leave it. So leave it as it is. The environment variable, and make sure on your ci.yml there is an environment variable. We need in our pipeline, actually we need .env here, so we can make sure that it can see our database. And let's go ahead and add this one as well. So okay, so we want to add how to add it on Vercel. Basically, let's take it step by step for now. Example of we can add it on with database. So this is the test that's going to run steps. So now I'm actually supposed to push it, right? Then GitHub CLI, and it's supposed to work. We don't have to use Docker recommended for your project, so we can just push to GitHub now. I think at least it's going to perform the do you want to install the recommended GitHub action extension? Yes, please. We have to install GitHub actions here, and sign into GitHub was also allowed. This will simplify our no, not this one. Actually, this is a different 1 second. Use another account. It's opening here. 1 second, I'm just going to copy this one. Let me see if I can do that. Paste this one here and paste it here. Let me see. Okay, continue with the login. You're already signed in, so let's see if it's actually working. Yes, continue. Authorize Visual Studio, yes. So let's just go ahead and push the code now. I think we are now we have some issues here. Unrecognized named value secret. So basically we mean not sure about this actually. Without this, let me go ahead. Not sure we need this because it's asking GitHub So I'm not sure we need all this stuff, but I think we will need this only in case we want to deploy it with Vercel. But anyhow, I really want to try this one. Okay, leave it as it is, just check it. Okay, I'm just going to go and try to go ahead and just run this one. Git add no. Git commit. Match any file known. Let me go back to my GitHub production flow. Git commit. Yeah, I think we should use double quote here. CI/CD and do this and let me just go ahead and open this one, my GitHub. Yes, I'm already signed in, but let me go ahead. I think it's this one. Yeah, so let me get actually it's working, I guess. Here you see this one, CI/CD now in progress. You have an option here, actions. It's actually doing something. Okay, it's actually doing something. So here we first thing it did, set up a job, and then yeah, it failed because there is one test here that we didn't do properly, I think. That's why it failed. And the test here, playwright, okay, but one test passed. So there is an issue with our test. That's the reason why it's not running. But it worked, يعني CI/CD actually worked. It worked. The concept, we got it, but we want to check like if we can see the GitHub documentation, just to see if we can find GitHub docs here. Yeah, this is much better actually. Yeah, here we have CI/CD and DevOps. Let's go ahead with GitHub Actions here. So automate, customize, execute, yes, and quick start. Okay, for GitHub Actions. GitHub Actions continuous, and so I think create your first workflow. So we just have to, in your repository on GitHub, create a workflow file called this one, GitHub Actions demo.yaml, in the GitHub workflow directory, just like we did. If the GitHub directory already exists, navigate to directory, click add file. Okay, the main page, add the file, and creates. Okay, this is done. For GitHub to discover any GitHub action workflow in your repository, you must save the workflow files in the directory called this one. Just remember this point. We have to add this name, this folder. Okay, you can give the workflow file any name you like. You must use .wml or WAML, YAML file, as the file extension. YAML is a markup language commonly used in configuration. So this is one sample actually they gave us, and we can use it as it is. We don't need to look up elsewhere. Yeah, the job is automatically triggered by this. The job is now. No, this is just a sample actually. They don't have mentioned at this stage. You don't need to understand the details of this workflow for now. You can just copy and paste the content to the file. After completing the quick start, you will learn the syntax of the workflow. So all we have to do is just copy this one, click commit changes and propose changes, create a new branch, select either an option to commit the default branch, create a new branch. Okay, so choose a pull request. If you choose to start a pull request, you can continue and create a pull request for the purpose of quick start. Okay, so the workflow results, we can see it here in actions, under actions here. From the list of workflow runs, click on the name of the runs you want to see. In this example, username is testing out GitHub actions. On the left side, workflow run page under explore GitHub actions job. The log shows each file. Yeah, I saw this is what we did, and you can see the list of file in each repository. Okay, the example workflow you just added triggered each time the code is pushed to the branch. So what we need is using workflow template to create GitHub action. See workflow template here. For continuous integration workflow, building and testing your code, for building publishing package, we have here also more. Deploying project, we have here automating task and process in GitHub. We have here so all this stuff we have it, so we have to check it actually one by one. We have to go it. So GitHub action, the component to be triggered when an event occurs in your repository, such as pull request opened and running. It's a specific activity repository that triggers as a workflow to run. We understand job is just a set of steps in a workflow, what's executed on the same runner. Each step is either shell script or something. Action is just predefined reusable set of jobs or code to perform specific task within a workflow. Runner is a server that runs your workflow when they are triggered. Can help you automate this one. This is just details. We should follow actually this one, workflow. So we can, if you already have a workflow in your repository, create new workflow. Page selection template, find if the workflow template contains comments, accompany many of the workflow template for building project. So we just want to try something here. This obviously failed. I want to see something here. Go to actions, filter workflow. This is the workflow that I created, so I don't really, I want to create a new I want different workflow here. Let me see if we have another workflow here. Building and testing your code. You can automatically build and test with we want to do actually with Next.js because that's our application, but basically it means Node. Choose a workflow page, show the selection recommended to search. Okay, I'm supposed to search actually from the GitHub actions here. let me type next JS or next JS node JS. Okay, the log section is not yet available. Okay, workflow type. Okay, because we didn't have anything here, so remove this one. CI pipeline, we only have this one actually, which is this one workflow run results. But there is an option to create a new workflow here. Choose a workflow, build and test, deploy, branch management, issue triaging and stuff. So I can search here. I don't need to search, I can find it here actually. Continuous integration, Node.js, automation. We have Next.js here. Let's see what it is here. So this is for Next.js. Sample workflow for building, deploying Next.js sites to GitHub pages. It's just not doing anything though. It's just okay, this is for deploying and stuff, right? What about testing, continuous integration, testing and all that stuff? Let's see here. We have here, let's see, let's try this one. But basically we already have workflow. We have different samples here. Webpack, publish Node.js package. Yeah. So let's go ahead and see more about this. We have templates there, and building and testing Node.js, publishing packages. Let's say Docker image into a registry, and deploy third-party platforms, GitHub Actions. Let's say we want to deploy it to yeah. So basically the issue is the testing. Okay, so our tests actually, this is failing first of all, and I'm not sure why it's failing, but it's failing. And let me type npx prisma and generate first. And okay, end-to-end is failing. Okay, I'm assuming this is failing, but at least this tool has to. Okay, I'm going to show you how to we're going to link the we're going to try to deploy it. Actually, I'm going to use Vercel for this to deploy my application. Let me check first what is my application exactly. Post, just a simple application. It's nothing actually, there's nothing there. Let me check what we will get, what result we're going to get, if it's even running. Yeah, it's running, so we should be able to get something actually. If no, we'll add some content just for the case of. So for deploying for Next.js application, actually Vercel is the best. Provide developer tool, cloud. So runaway build time went. So I'm just going to start deploying here. I'm going to log in first. Okay, I'm just going to connect it to my GitHub actually. Okay, now that we connected it to our GitHub, it will automatically actually sync all the repositories that are available in our GitHub in our Vercel. Okay, you just need to create an account in vercel.com, and then we have this application, right? Then we can import this repository, and it's a Next.js application. We can go ahead and actually run it. you know. But I think import env. I'm just going to import the .env from the desktop. Here we have my full stack. Yeah, this one, this .env. Okay, this is where we are putting the username and password. These are the yeah. So let me go ahead and run this one. Okay. Yeah. So this yeah. So the reason is it's not working now because there is an issue. Okay, that's what we should try to do right now. We should try to fix it. And before running, actually, it's always better to run this command npm run build, so we can identify what exactly are the issues that we can face on the production environment. There is no issue, so it seems like it's all okay for production. The issue must be due to the CI/CD pipeline we have here. Without CI/CD, it would have worked, but the CI/CD pipeline we created, it's failing the action. You see CI/CD failure, you can see it here. It's failing because actually the test is failing and these are failing. Okay, I understand now, and I know how to fix this one. Actually, this is not that much difficult to fix, but let's go ahead and do it. Remove this unnecessary stuff and leave this one as it is, and let's just go ahead and this is what I will do. I will push this to the main. Let me go ahead to the Git repository. I'm just going to push I think that's the thing that's missing. Okay, let me go ahead and push the git push origin. Please make sure you have the correct address, right? Git repository. Okay. Git checkout. I'm just going to create a new branch here. So check out, just to make sure. Feature testing. Not feature, just added testing. Just name it testing, whatever. And then I'm just going to git add dot. Okay, and then I'm going to git commit -m and feed, and just mention testing added unit test and integration. Okay, just for the sake of finishing. Okay, now that we have yeah, so we just remove this too, and let us go ahead and push git push origin to check out testing. No, change this to push